Night 3 is about limiting reactants and percent yield. We're going to be breaking this into 2 different days worth of lessons. And the first lesson we're going to look at will be limiting reactant. So let's go back to our sandwich. So the equation or the recipe to make a sandwich, we need 2 pieces of bread, 1 piece of cheese, and 1 piece of ham to make one sandwich. So you go to the kitchen and you have 7 pieces of bread, 2 pieces of cheese, and 3 pieces of meat. We want to decide how many sandwiches can we make. Well, if we have 7 pieces of bread and it takes 2 pieces of bread to make a sandwich, we could make up to 3 sandwiches with the bread that we have. And then we're going to have some bread left over, right? If we look at our cheese, we can only make 2 sandwiches with the cheese that we have. We can make 3 sandwiches with the meat that we have. So the most amount of sandwiches that we can make would be 2, according to this recipe or this sandwich reaction. So in this case, the cheese limits how many sandwiches we can make. So we would call the cheese the limiting reactant. So if we made our 2 sandwiches, then we would have 1 piece of meat left over. We would also have, if we're making 2 sandwiches, we're going to have 3 pieces of bread left over. The bread and the ham are considered excess reactants because we would have ingredients left over if we make the 2 that we can make that with our limiting reactant. And so we're going to be looking at this in terms of chemical reactions and then the reactants or the things that go into the reaction for chemical reactions here. So the limiting reactant is the reactant or the ingredient that limits the amount of products that you can make because you have plenty of the other reactants. The other reactants that you've got enough of that you're going to have some left over are called the excess reactants. So if we take this equation, first of all, keep in mind we're talking about limiting and excess reactants. So we're talking about the reactants. So our problem says we have 2 moles of HF and we have 4.5 moles of SiO2. So those are the amounts of the ingredients that we have on hand. We want to know which is the limiting reactant. So when we answer this question, we're going to say either the 2 moles of the HF is the limiting reactant or the 4.5 moles of the SiO2 is the limiting. So that's how we're going to state our answer. How do we determine this? So we need to see which of these is going to make the least amount of product. At this point, if it doesn't tell you which product to go to, you can pick one. So we can either pick SiF4 or we can pick water. I'm just going to pick water because everybody likes water. So we're going to take both of these and convert them to moles of water because moles to moles is going to be less steps than if we go moles to grams. Sometimes it might tell you figure out how many grams of product, but if it doesn't, you can just take it to moles. So we've got 2 moles of HF, so moles of HF on bottom, and now we can switch, so moles of H2O on top, moles of one substance and moles of the other, so we need our ratio, so 2 and 4. So that means this is going to make 1 mole of water. And then moles of SiO2 on bottom. And again, we're going to moles of water. In every one of these limiting reactant problems, you are going to be going to the same thing. So the top part and the ending part of your stoichiometry problems are always going to be the same. So coefficient there is 1. So this is going to make 9 moles of water. So once we have determined how many moles or how many grams, whatever we're looking for, of the product are made. So this makes 1 mole of water and this makes 9. So we want to look at which one makes the least amount. That is the limiting. That's going to limit how much we can make. So since this is the least amount of water produced, our answer to which is the limiting reactant is 2 moles of HF. Looking at the next one, again, I have balanced all these, but you do have to have balanced equations. Which is the limiting reactant when in this reaction when we have 0.75 moles of N2H4? So we're going to write that down. And we also have 0.5 moles of H2O2. So it doesn't tell us which product we have to go to or if it has to be moles or grams. So I'm just going to pick, in this case, I'm going to pick N2. So we're going to take both of these to moles of N2. And moles of H2O on bottom, H2O2, and that's a 2 to 1. And then up here, moles of N2H4, that's a 1 and 1. So this is going to make 0.75 moles of N2, and this is going to make 0.25 moles of N2. So this is the least amount made. So my limiting reactant is the 0.5 moles of H2O2. Now, this is a continuation off of the last one. How much excess reactant in moles is left over? Well, we determined in the last problem that the 0.5 moles of H2O2 was my limiting reactant. So this is a limiting reactant, which means that the other reactant is my excess reactant, that we're going to have some left over, just like we had some bread and some meat left over. So this says how much of the excess reactant in moles is left over. Well, with the cheese, if we had 2 pieces of cheese and then we had 3 pieces of the ham, and we're going to make 2 sandwiches, we only need 2 pieces of ham. So that means we'd have 1 piece of ham left over. That's basically what we're going to do here. So we're going to take our limiting reactant, and we're always going to start with a limiting reactant once we have determined what that is. We're going to take our limiting reactant and convert it to the moles of, because it says in moles, the excess to see how much of that we're going to actually need. So moles of what we're starting with on bottom to moles of what we're going to on top. And this is a 1 to 2 ratio. So that means we're going to need 0.25 moles of N2H4 to react with all of the 0.5 moles of H2O2 that we have. That's how much we're going to need. This wants to know how much is going to be left over. Well, we started, and if you go back to the previous equation, it said we started with 0.75 moles of N2H4. We're going to use 0.25 moles. So how much is left over would be 0.5 moles of N2H4. And that would be our answer. Now the next one says, how much of each product in moles is formed? So we're still working on that same problem. We still have the limiting reactant was the H2O2, and there were 0.5 moles of that. We figured out in the first problem how many moles of N2 were formed. So we can just go back and write that down. And if you didn't take notes, we produced 0.25 moles of N2. Now we need to figure out how many moles of water we would produce. So always start with your limiting, and now we just have to take it to moles of water. So moles of H2O2 to moles of water, and this is our ratio, so 4 to 2, and that's going to tell me 1 mole of water is formed. So that and what we figured out before would be our answers to how much of each product in moles is formed. All right, let's look at this next one. Again, make sure it's balanced. I have done that for you. So we have 20.5 grams of chlorine and sodium. So we're going to write that down. 20.5 grams of chlorine. And remember, chlorine, the formula says Cl2. And then 20.5 grams of sodium, Na. Which reactant is in excess? And half the battle on these is answering the question that it's asking. So we basically have to figure out what is the limiting and then figure out which one's the excess. So we only have one product, so we have to take both of these to NaCl. It does not tell us grams or moles, so we're just going to do moles because that's the easiest. Chlorine, we have grams of chlorine, so that has to go on bottom. Remember, it's Cl2. We have to get it to moles first because we need to be able to switch. So grams to moles of chlorine, and that's 1. And chlorine's 35, but we have 2, so 70. Then moles of chlorine on bottom. And we're going to moles of NaCl. Our ratio is 2 to 1. So when we do 20.5 times 2 divided by 70, that's going to give us, let's see, 20.5 times 2 divided by 70, and my calculator says 0.59 moles. All right, for Na, we're going to do the same thing. So grams of Na on bottom, and that has a mass of 23, 1 mole of Na. And then moles of Na on bottom, and moles of what we're going to, NaCl, on top. That ratio is 2 to 2. So when I calculate, I'm going to take 20.5 divided by 23, and then the 2's cancel out, so I don't have to worry about that. And that's going to give me 0.89 moles. Okay. So the one that produces the least amount, this is my limiting reactant. But the problem says which is the excess. So the answer on this one is going to be 20.5 grams of Na. So again, watch that wording because it's very tricky. Let's look at one more. All right, let's see. Is this the one we want to do? Okay. All right, so we have 36 grams of water. What just go ahead and write that down, is mixed with 167 grams of iron. Which is the limiting reactant? So we're going to pick out which one to go to. We can pick this product or this product. Probably the easiest is H2. So we'll just take both of those to H2. And again, it doesn't say grams or moles, so moles is easier. We're going to go to moles of H2 and then compare. So grams of water on bottom. We have to get that to moles of water. H2O. There are 18 grams for the mass of water and 1 mole. So now moles of water on bottom. And now we can switch to moles of H2. So my ratio is 4 to 4. And that's going to give me, let's see, .36 divided by 18 should just be 2 moles of H2. Then on the bottom, again, we're going to take it to moles of H2. So grams of Fe on bottom, and Fe's mass is 55.8. So 1 mole of Fe, moles of Fe, 2 moles of H2. So there's 4 to 3. And so we're going to solve. So 167 divided by 55.8 times 4 divided by 3 gives me 4 moles of H2. So my limiting, for which produces the least, is going to be the 36 grams of water.